right, and here is problem 9. So here u and v are differentiable functions of x and y. Prove the product rule for the gradient. So I suppose to prove, well, in this case, to prove means to verify this equation. Nabla of uv equals v times nabla u plus u times nabla v. Okay, so let's just verify it. So this is going to be the left hand side of our equation, and this is the right hand side of our equation. So we just need to check that basically that the left hand side equals the right hand side. So let's just find out. Okay, so the left hand side is nabla. Oh yeah, a nabla of anything, so is by definition is the vector whose entries are partial derivatives of f with respect to f and y, right? So nabla of uv is the vector whose entries are partial derivatives. So let me just maybe write with d over dx uv. Maybe it's clearer. D over dy of uv. So now, how can we do it? So we've got to apply the product rule to find it out, to compute it, right? So to differentiate the product of two functions, u and v, with respect to x, what we do is going to be the partial derivative of u with respect to x times v plus u times the partial derivative of v with respect to x, right? So this thing is partial differentiation of u v with respect to x. The second entry is well, basically the same thing, only we are now differentiating with respect to y, right? So it would be u differentiation with respect to y times v plus u times differentiation of v with respect to y. This is d over dy of uv. Well, I guess we can't really continue any further. It's not clear whether we should somehow try to change it or not, right? So that's the final answer, right? So this was the left hand side, right? So I mean, we need to check that the left hand side is the same as the right hand side. So now the right hand side. So the right hand side. Let's do the right hand side. So v times nabla u. So let me just copy it first. So v times nabla u plus u times nabla v is what? So v times nabla u. So nabla u is u differentiated with respect to x, and u differentiated with respect to y. So it's a vector whose entries are partial derivatives of u with respect to x and y, plus u times nabla v. So it's going to be u times partial derivatives of v with respect to x and y. All right, so now when we multiply a vector by a scalar, it's the same thing as to multiply every entry of the vector with that scalar. So we can basically insert it inside the scalar. So it's going to be vux, vuy, the first vector, plus the second vector is u vx and u vy. This is the second vector. So now we have two vectors. So when we add two vectors together, we basically add the first entry together, and then we add the second entry together, right? So the first entry of this vector is going to be this plus this, right? So vux plus uvx. And the second entry is going to be this and this. So vuy plus uvy. Okay, that's it. And now we just want to compare. So is it the same as the left hand side? And the answer is yes. I mean, if you just look at these two expressions, this expression and this expression, they're the same, right? So it's just the same as the left hand side. So that's all.